Well, hello and welcome to another DevNation. We have another live session today that's going to be super fun. There's already a huge amount of you on the line with us right now. What I would want you to do is make sure you get your questions into our chat tab or Q&A tab. I will try to answer as many in real time as possible, and then we'll hopefully have some to save towards the end. Also, other members of the Red Hat team are here, like John. I see him online, so he can also answer questions. So do throw questions into the chat tab, into the Q&A tab, and we're going to really have a lot of fun today. Now, we're going to be talking about this thing called Quarkus, this supersonic subatomic Java, where if you love Java and you want to see Java running insanely fast, insanely small, and having a lot of fun while you develop it, that's what Quarkus is all about. And Georgios is here to show us the Spring variant. So if you're just in the Spring APIs and what we've been doing in that category, you got the right man for the job, because he's going to rock and roll right through that. If you can't hear or can't see, meaning you can't hear or see what I'm saying right now, refresh your browser and turn off all those ad blockers. That's the secret for this. All right, let's turn it over to Georgios. Georgios, you're up.
Hey, Burr. Hey, folks. First of all, thank you very much for having me here. Thanks for everybody for attending, and let's get the show on the road. So I know you've heard a lot about Quarkus through all these awesome sessions here, so I'm going to go through insanely small amount of slides really quickly, since I know you've already heard all this great stuff about Quarkus. I'll just refresh your memory real quick, and then we'll go straight to the demo. That's the plan, at least. So let me start sharing. And let's go. All right. So here we go. Small amount of slides, and then we'll go through the demo. Okay, so Spring Apps on Quarkus. What are we going to show here? We're going to talk initially about Quarkus. So you know Quarkus from all the previous sessions, that it's an open source stack for writing Java applications that usually target like microservices or serverless environments. Anything cloud native. The four main benefits of Quarkus that we've iterated and we've talked about over and over again, and we'll see a lot of these benefits today, are first, developer joy. Developer joy, by developer joy, we mean that you as developers, as users, when you use Quarkus, we want you to feel that you are really productive, that you really get your job done really quickly and have fun while doing it. We'll really see what that means in the demo. Second part, which is super important, and it's obviously supersonic and subatomic Java. What that means is that the applications you develop will be very small and will be very well suited to be deployed to the cloud. The third benefit is that Quarkus unifies the imperative and reactive programming models. We won't have time to talk about that today, but I'm sure you'll find some excellent material out there for using reactive stuff in Quarkus. And finally, that Quarkus brings you the best of breeds libraries and frameworks and standards that you've been accustomed to all these years and that you've been using in your Java applications in order to be productive. You've probably seen this slide before, and you'll see some very big names out there. I mean, all the stuff that you typically use in all your enterprise grade Java applications, Quarkus really has you covered. You'll see like MicroProfile, you'll see Hibernate, you'll see REST-easy, Camel, all the great stuff. You'll see all the cloud native stuff, Kubernetes, OpenShift, and in the middle there, you'll see the Spring compatibility layer, which is what we're going to be talking about and demoing right now. So that was it for the slides. Hopefully I didn't bore you too much. I'm sure you already know all this stuff. So let's get into the stuff that you might have not seen yet. So what I'm going to do, I'm going to initially create a Quarkus application using our command line tooling. You don't have to use this command line tooling. You could just use code.quarkus.io, which is our excellent code generation page where you can create a project. What I'm going to do here, I'm going to use the Spring Web extension. If you see here, I'm going to be using the Spring Web, which will create a Quarkus application that's already set up to use Spring stuff. And I obviously made a mistake right off the bat. I used the wrong package name, so let's do DevNation 2. And that will hopefully work, and I got it right this time. So I'll open this in my IDE. And let's see what we have here. So what this generates is a regular Maven project. And the difference between this and the other Quarkus projects that you might have seen is that it adds the Quarkus Spring Web dependency, which is the dependency that we'll use to create REST APIs. And because it added that, you won't see any JAX-R REST resources for creating REST applications. What you'll see is your regular Spring controllers. So this is a Spring controller that you would normally have and be used to if you're using Spring Boot or maybe even Spring Framework without Spring Boot. So this is all just normal stuff. What we're going to do now, though, is kick off our developer joy and start being productive. So how do we do that? We do MVN Quarkus dev. So what this does is that it launches the dev mode. The dev mode is the awesome mode that Quarkus has that allows me to write code and instantaneously see feedback, see the results of what I'm doing without having to restart the application at all. So I started the application here. I'll go real quickly and make sure that everything is working. So this is the Spring controller that it was automatically generated for me. It just returns a hello. I'll change that real quick here in the IDE. Won't do anything else, just refresh. And I immediately see that. So you see something that you're not used to in the Spring world, but that is so vital to Quarkus, that you write your changes in the IDE or your whatever text editor you use, and you immediately see the changes. So I'll go ahead and make this just a tad more complicated. I'll add a request param. The request param here is that I'm just going to add a query parameter. So request param is what Spring uses for the query parameters. I'm going to give it a default value of world, which means that if I don't pass the query parameter, it'll be hello world. If I go here and add DevNation, then it's hello DevNation. See, instant changes. That's all great. But I'm just returning a string here, right? Strings are boring. So what we want to do is we want to return some JSON. JSON is what every web service uses these days. So I'm going to create a class. I'll say string, let's say message. And I'll create a constructor and add my getters and everything. And then here, I'll go and change the result to be a greeting. And I just refresh and I magically see this stuff happening, right? I magically see JSON just by writing the Spring stuff that I already know. So let this sink in. This isn't like different Spring than what you're used to. This is, you just write your Spring stuff that you've no doubt have been writing for a while now, since a lot of people use Spring Boot. You just write this stuff and you're immediately productive, and you're so much more productive than you're used to because of this dev mode that automatically allows you to see your changes. Let's make some more changes and make this a little more interesting. Let's say greeting service. So a greeting service is what I'll use to, like, let's say, encapsulate the business logic here. String name, greeting. And I'll say hi, name. I'll go back here. I'll inject this greeting service into my controller. Greeting service, greet name, and I think I did a fairly good job here. Notice I didn't use any add inject here because this is there's only one constructor, so we can automatically deduce that that's what's supposed to be used, just like Spring. I refresh, oops, and I see an error. And that's great, right? That's great that I can see the error right inside the browser. I see it immediately. And it's the error staring me in the face, right? It just tells me unsatisfied dependency of type greeting service. And what does that mean? I mean, I created a greeting service, but I forgot to make it a bean. So all of us have made this mistake before. So all we do is just add a Spring service annotation, or I could use component or whatever I like. I'll refresh, and I just see my changes. And that's great, right? So developer productivity and developer joy doesn't mean that only the happy path works. It means that I get meaningful feedback immediately when I make a mistake. And now I'm going to top this off by, let's say, making this configurable, because I don't want this this high thing to be hard coded, right? So I'll make this configurable. I'll have a prefix, and I'll go oops, that was wrong. Value is what we all know from Spring, to inject configuration. So I'll go greeting prefix, and then I'll add the prefix here, and I should see more awesomeness. And I do see more awesomeness from Quarkus, not from me, that is, because I made a mistake. I said no. I immediately see what the mistake is. I see no config value exists for greeting prefix, and that couldn't be more obvious, right? So I obviously forgot to go here and say greeting prefix is hola DevNation. So I made changes not only to the source code, I made changes to configuration. Then it was picked up immediately. So that's pretty cool. Maybe let's take it a step further, and let's say I want to post something, but I want to also have validation on what I post. So for that, what I would do is that I would add a new dependency, which I'm going to say, which is going to be the Quarkus Hibernate Validator, which is going to provide me with validation for my input. So let's say I go to the controller. I'll go public static class input. And let's say, I don't know what to call it, so I'll just call it field. Not really imaginative, but it'll do. And then I want to, let's say I want to return a greeting, but I'll say like from input, and this would be input, and this will be a post mapping because I want to post this. Post mapping is what Spring uses these days. And I'll make this valid. And I'll add a constraint here. I'll add like a simple constraint like not blank. What that means is that when I post to this method, then I expect that the field will not be blank. And let's say new greeting, hi from, and I'll say input get field. Now, since this is a post, I can't really use the browser without developing a UI, that is, which is something I don't want to do now. So I'll go ahead and use HTTP, which is an awesome command line tool. It's called curl. Some people call it curl for humans. So I'll just use that. I'll just go post localhost 8080 greeting, and I'll say field is George. So I post that and I get hi from George, right? Because that's what I expected here. Now, if I do a blank field, I should get I should not get an HTTP 200. I'll get an HTTP 400, which is a bad request. See, and I didn't specify an exception handler or anything, so I just got the out of the box stuff, which tells me that the input field was blank. So you see that all the stuff you're used to from Spring web controllers, REST controllers, just works out of the box, right? And it works great with Quarkus. Well, that's cool, but you know, without a database or anything, there's only so much stuff we can do. So the next logical step is to use a database, and the way we use databases usually in Spring is to utilize the Spring Data JPA abstractions. So what we'll do here is we'll add one more dependency. We'll use the Quarkus Spring Data JPA extension. And because I'm running an H2 database locally, I'll just add the GDBC H2. This is like the Quarkus extension to talk to H2. So that's we got that out of the way. And let's go and create a book. The book is the entity I'm going to be using. I'm going to call it book. It's going to be super simple. I'm just going to add integer BID, which is going to be the book ID. And I'll give it a few fields. I'll give it name, and let's say integer publication year. So those are the only fields I'm going to have. I'm going to add some getters here just to make the serialization easier. Those are the only fields I'm going to add. And in typical Spring Data fashion, Spring Boot, Spring Data fashion, I'll access this book from the database using a book repository. So this is the pattern that Spring Data JPA uses, where you extend a repository. You say which entity the repository is for and what the type of the ID is. So book repository, I don't have to write any code except this, like just an interface that extends Spring Data JPA's CRUD repository. And now we want to be able to access that. So I'll write another controller. I'll call this the book controller. Let's see, request the REST controller, request mapping, and we'll say this is under book. I'll inject the repository, book repository, constructor injection, as we're told so often we should do. And public, let's say I'll make this an iterable books, and I'll say find all for book repository, find all. I'll make this a get mapping. So I think I'm done with coding this, but I still have I have to configure Quarkus to talk to the database. So what I'm going to do now is that I'm going to paste the configuration I already have. So like I said, I'm talking to a local H2 database. I'm going to use the H2 dialect, and I'm just for the ease of this demo, I'm going to be dropping and creating the database every time Quarkus. Every time I load it, change with Quarkus. And now this awesome feature that Quarkus has is that it allows me to seed the database really easily by adding some data to the import SQL file. Import SQL will allow me to just add a few SQL statements, and so I can have some books to interact with. So these are a few books I've been reading lately, and I'll be using them to show that hopefully the code I wrote actually works. So what do we need here, right? All we need here now is to go to book, and hopefully I'll see all my books if everything goes well, and I do. I mean, I have of the 6 books I added, I can access them immediately. So let's reflect on this part a bit, right? You saw that I never restarted Quarkus. All I did was just add a few dependencies, write my code, and I immediately got access to the database. Like, this was so easy. It took me like 5 minutes, maybe 10 minutes, to write something that utilizes APIs that I already know, and I love the Spring APIs. I see these are all Spring APIs. You see the imports. There's only Spring stuff. You go to the repository, you see only Spring stuff here as well. And Quarkus just worked out of the box so fast. This stuff worked immediately. So that's pretty, I think, is pretty mind blowing. We can do more stuff here, obviously, right? So the book control. Let's say I'll add another method, and I'll say list, like I would do with Spring Data GP. I want to add some custom methods. So I'll go find by publication year between integer lower, integer higher. So what this will be doing is this will allow me to query the database for books that are published between certain years. Let's see, how do we do this? Get mapping, I'll say year, I'll say lower and higher. And path variable, this should be Spring's path variable, that's correct. Another path variable, and then I'll say book repository, find lower, higher. So I'll go here again, and then I'll go year, let's say 2010, 2020. I see all my books immediately. Like, it's like I didn't even know that Quarkus dev mode was in play here. It just worked immediately. So, and then if I want to narrow this down, I can say 2017, 2018. Immediately, I have all my books here. So I think this is pretty amazing. Now, one other thing that we've heard about a lot about when it comes to Quarkus, right, is that you can create a native image. A native image is the creation of native images is done by GraalVM, which takes our jars, the jar that Quarkus creates, and it creates a native binary. Quarkus that makes that super easy to do. So all I would need is like mvn clean package. I would skip tests. You should do this. But I'll just show this real. I'm not gonna let it create the native image because that will take a couple minutes, and we have better things to do than sit around and wait for this to complete in a couple minutes. But what I wanted to show you is that you create with a simple command line flag, which is the -d native. I could create the native image, and Quarkus will take care of all the difficult things of creating native image with the Graal VM. So I'm not going to let that complete, but what I'm going to do is that I've already created it for you before starting the demo. So I'm just going to start it here. DevNation. You saw this. You didn't even have the time to see how fast this happened. So I started the application. Let's note this point. This is a Spring, a Quarkus application with Spring API. So Spring Data JPA, Spring Web. It talks to the database, the H2 database. It has Hibernate Validator, and it started in 18 milliseconds. I think you'll be very hard pressed to see anything faster than that. And let's just make sure that it works. And it did. I mean, native image, 18 millisecond startup time. And let's see another great thing about it. Let's see how much memory it takes up. And so the resident set size for this was 42 megabyte. 42 megabyte for a database, a Java application that talks to a database, I think is pretty amazing. Hope you all agree with that. So that concludes the first part, let's say the coding part of my demo. The next part I wanted to show you real quick is that why does this actually matter in a cloud environment? And what I'm going to do to try to show you this is that I've created Burr really created this actually, and I let's say was inspired by it. So this is it's the same application written in 3 different ways. It's a vanilla Spring Boot application. So I'm using latest Spring Boot 2.2.2.1. It's just a Spring application that returns some JSON, right? That's it. The other version of the application is the Quarkus application that basically it's the same Spring controller, but it uses the Quarkus stuff, the Quarkus Spring stuff that I showed earlier. And it's the Quarkus 101 finalized version. And then I also have the same version of the application written in Node.js. Don't even ask me how I did this. I don't even know, since I'm not a Node fan. But what I wanted to show you with this is that a lot of people use Node.js because it has a low memory footprint and starts real fast. So they use it a lot for the cloud. So what I want to show you is that how Quarkus compares to these two environments. So what I have here for you is what I have here on the top of the screen is a script that is counting how many ready pods we have in our Kubernetes cluster. Oh yeah, I forgot to mention that I've pre-deployed these 3 applications, these simple applications to OpenShift cluster. And for those of you who don't know, OpenShift is Red Hat's enterprise version of Kubernetes. So you can just think of it as Kubernetes. So I've deployed the Spring Boot application, which is on the left, Node.js application in the middle, Quarkus application on the right. I've deployed it to OpenShift. And what I want to do now is that because I'm using OpenShift serverless technology, which is based on Knative, what I'm going to do is I'm going to simulate a burst of traffic, and I'm going to see how quickly my cluster can scale up these applications, which let's say again, these are the same application. One is in vanilla Spring Boot, one's Node.js, one's Quarkus. So I'm going to start simulating the traffic first for the Spring Boot version, then for the Node version, and finally for the Quarkus version. So Quarkus is at a disadvantage here because I started the burst last. But what I want you to feast your eyes on is the top, right? The script that's monitoring how fast these can scale up. So we immediately see that although Quarkus was the last one to start receiving traffic, it immediately scaled up to 13 pods without the other ones having scaled any they just have the one pod. Now Node.js is coming up. So you see how long it took for Node.js to come up. Vanilla Spring Boot isn't even up yet. There's still one pod running. So in a real environment, you would have missed all this. If you were running with a vanilla Spring Boot, you would have missed all this traffic. And you saw that if the same application, if you had it in Quarkus, it would immediately start serving your large traffic boost and burst. Let's see now. The Spring Boot is trying to come up. So my OpenShift console here is showing me that there are a lot of pods running, and Spring Boots are trying to come up, but they're not. So you should note that this cluster is a fairly slow cluster, right? So these are starting up slower than they would. But in any case, the difference between the three types of applications would be the same, whatever type of cluster you have. The other great thing to note here is that OpenShift will show me the top 10 memory consuming pods. And you can see here that they are all from the vanilla Spring Boot. None of the Quarkus applications even makes it into the top 10 memory consumers. So you immediately see that you have an application that starts so quickly that you can actually serve burst traffic, and it takes up a lot less memory, which means that you can pack in a lot more of the instances of the application. So I really hope that this whirlwind tour of what we can do with Quarkus and the Spring on Quarkus really gave you the opportunity to see the power that exists behind Quarkus and what we've done with it so far. So I think I stopped sharing now. So I think what we have.
All right.
What do we have?
We do have a couple moments
for questions, Bert.
We do have a couple moments for questions, and I think there's one in particular that's very appropriate for you, and that is, how are we going to manage keeping up with the upstream Spring? So if Spring continues to evolve and move along, what is your plan for addressing that? Yes. I'm hearing you.
Hearing anything.
Oh, well, we can talk this way. So the question is, how do we keep up with the upstream Spring? As Spring evolves and continues moving forward, what are your plans to continue keeping up?
Okay. Do you want me to take this one, or?
That's you.
Okay, great. Okay, so the idea here is we want to provide like the most common features that Spring developers use, right? We obviously can't compete like in bringing every Spring feature that's out there, but what we want to do is we want you to use be able to use the most common Spring features and be able to use them in a way that is like, let's say, better than you would use with vanilla Spring Boot, in the sense that you have that they're faster. It's faster for you to develop, and applications you build have a much smaller runtime footprint. We have Spring DI, Spring Web, and Spring Data's APA. In a few days, we'll have Spring Security support as well. And then we have a lot of more stuff on the pipeline, but we really want to hear from the community, like what the most important things and most used things are from people, and what they want to see from this Spring effort on Quarkus.
Okay. And a question related to Spring REST controllers. Do we have support for HateOS or HateOS, depending on how you pronounce that?
Yeah, that's another. We don't have that yet, but that's one thing that we have heard from a few people. And like the more we hear from the community for this stuff, then easier it is for us to justify. Okay, like let's go the extra mile and put this in.
Okay, and I'm just checking a couple other things. It looks like we covered most every question that I can think of, at least the ones we can cover in the time that we have remaining, because we are out of time. But I really enjoyed the presentation. I really loved the demonstration. That was absolutely fantastic. John Klingham has been there answering questions also. You did show things like Spring JPA, so that's the at repository syntax. I remember you covering things like that. So otherwise, I think awesome job here. We had a huge crowd on the line today. I apologize if we missed your question. They were coming in fast and furious, but do feel free to check out Georgios on Twitter. And actually, I will add his Twitter account to the chat so you can check him out on Twitter and find him there. You can always come to the Quarkus Google group, and that's where we all hang out, and Zilloop group, as John says right there in the chat. Definitely bring all that to us, and please bring us your questions. And if there is something in the Spring universe that you truly must have and love, please let us know. We're very interested in hearing about that use case. Again, thank you all for your time. Georgios, awesome job as always. Thank you.
Thank you, Burr. Thanks everybody for attending. It was great being here. Thanks so much.
Absolutely. Everyone